Okay, continuing our last video here, we were looking at example 8.4, and we got to the point where we were calculating part B, or the potential energy at this halfway point here. Okay, so we were writing it down. We had mg times y sub b plus 1/2 times K, which is 6 Newton per meter, times our halfway point, which is going to be negative 0.2 meters, and that is squared. Okay, so if we do this in our calculator, let's see. So 0.2 squared times 6 times 1/2, and this is positive, plus 1.2 times negative 0.2, we'll get that our potential energy is negative 0.12 joules. Does this make sense? Let's see. If we have this here, y sub c is negative, u would be okay, yes, this does make sense. So we have that our potential energy at point B is negative 0.12 joules. Okay, and there is one more part to this. It states, what is the speed of the block at point B? Okay, so at point B, we have that, let's see, if we're looking for the speed, we will want to know the kinetic energy, right? So our kinetic energy is 1/2 mv squared. Okay. Our kinetic energy at this halfway point should equal, let me say B, should have the same value as U sub B, or potential energy at B. Okay. So what we will do is negative B, negative U sub B. Let me rewrite that. Trying to erase this. Okay. So the reason is because our total energy E is going to be K plus U, right? And at this point, delta, we should have K equals minus U. Okay, so let's see. We need to figure out what our mass is at this, or of the block. So we remember that F equals mg, or M equals F over G. Okay, our F was 1.2 newtons divided by 9.8 meters per second squared. To get, let's see, 1.2 over 9.8, and we get 0.12 kilograms. Okay. Now we can go ahead and solve for V here. So V then is going to equal, doing some quick math, we have 2 U sub B over, so minus U sub B, over M, and that is square rooted. Okay, so we have 2 times negative u sub b, which is then going to be 0.12 joules, and then divided by our mass, which is 0.12 kilograms. All that inside of a square root. Okay. And so then solving this, we get that our velocity is equal to 1.4 meters per second. Okay. I know this is kind of messy. If I had more space, I would have put it down there. But anyway, this is our velocity at point B. So 1.4 meters per second. Okay. All right, so let's go ahead and move on now to conservative and non-conservative forces. So the one that we really care about understanding is going to be the conservative forces. We want to understand how are they conservative, and how can we prove that they are conservative, okay? So conservative forces is that when a total energy, or the kinetic plus potential energy, at the start and stop are equal. Okay, so the kinetic energy initial and potential energy initial is equal to the final and the final of the potential and kinetic energies. Okay. And the work done by a conservative force is independent of the path taken. So it doesn't matter what path the force goes through, okay? It will have this work done here. So work done for path 1 is going to be equal to the integral of path 1 times the conservative force, that's what the CONS, that's conservative, okay, dot dr is equal to the same work being done from A to B of the second path, is equal to the integral of the second path, F conservative dot dr. So basically, if we have 2 points, A to B, if we have a straight shot, or if we have this crazy thing, okay, the work done is the same in conservative forces, okay? In a non-conservative force, it does depend on that path taken, okay? So, from A to B, the work done here is going to be different than the work done there. Okay, so again, that's in non-conservative forces. Okay, so going back to conservative, a force is conservative if the work it does around any closed path is 0. Okay, so any path, say like that, okay, if the work it does around that path is 0, then it is conservative. Okay. All right, so back to non-conservative forces. Again, it does depend on the path taken, and this involves dissipative forces such as friction or air resistance. Okay, so let's find some kind of condition that helps us define, oh, is it conservative or non-conservative? Okay, so this is that condition. The force must be an exact differential. Okay, meaning if we have some force defined as this, so F dot dr is equal to F sub x dx plus F sub y dy, okay, we can take the derivative with respect to y of F sub x, and that should be equal to the derivative with respect to x of F sub y. Okay, so maybe stare at this for a second here and notice the difference here. df sub x over dy equals df sub y over dx. Okay, so if this is true, then it is conservative. The force is conservative. Okay, so let's go ahead and do an example of this. Example 8.5, which of the following two-dimensional forces are conservative and which are not? Assume A and B are constants with the appropriate units. Okay, so let's go ahead and do A first. So we have this part here, which is going to be F sub x, since it's in front of this I hat here. And this part here is going to be F sub y, since it's in front of this j hat. Okay, so remember we are looking for df x over dy equal to df y over dx. So this is what we need to test. Okay, so the derivative of this first part with respect to y is going to be 2ax y squared. Okay, so I took the derivative with respect to y. So I left x constant and then took my derivative. Okay, now I'm going to do the same thing with f sub y. Take the derivative with respect to x, and I get 2a times y x squared. So are these equal? No, right? Okay, so this then is non-conservative. Okay. All right, let's look at B now. So this first part, dx, remember this is f sub x. So we have dy of a y squared over x. Okay, so we can write it that way. We're going to have 2y, times a, I should put, over x, right? Equal to dx of a 2y ln of x over b. Okay, so take the derivative of this guy. We get 2ay, which that's all the same. And let's see, this is just a constant, so we don't really care about it. The derivative of ln of x is 1 over x. Okay, and then, let's see, I believe the b will go away. So ln of x over b is equal to ln x minus ln b. Yeah, so that'll go away. Okay, so do these equal? Yes, they do. So this means that this is a conservative force. Okay. All right. I believe we're going to have to stop here. Part C might be a little bit longer, so I will need to get a new page ready for that. So I'll see you in the next video.